morning, everybody. How are you today? Today we will start with the first part of Chapter 2, Linear Momentum. The objectives of this session are determine the linear momentum of a particle, the linear momentum of a system of particles, and that of the center of mass of a system. The momentum measures how hard it is to stop a moving object. Look at the figure, please. Which is harder to stop, the truck or the bike? Of course, it is harder to stop the truck. Why? Because its mass is larger. So the momentum of an object depends on its mass. Now, let's reach the rule for the linear momentum of a particle. The linear momentum of a particle is given by the vector quantity p vector. So it is a vector quantity. It has a point of application, a line of action, a direction, and a magnitude. P equals m times v. So the linear momentum is the product of the mass of an object by its velocity vector. In SI unit, P is expressed in kilogram meter per second. Mass is expressed in kilograms and the speed is expressed in meter per second. Now, let us consider a system of particles. Consider a system of particles of n particles of masses m1, m2, etc. and mn with velocities v1, v2, vn, etc. The linear momentum of the system of particles is simply the vector sum of all the linear momenta of its particles. That is, P system equals P1 plus P2 plus P3, etc. equals summation Pi, where P1 equals M1 V1, P2 equals M2 V2, etc. So, P of a system equals M1 V1 plus M2 V2, etc. Look at the figure, please. Linear momentum of the center of mass of an object. First, as we all know that the position vector of a center of mass of a system is given by Rg equals m1r1 plus m2r2 plus etc. into mnrn, all divided by the total mass of the system. If each particle has a constant mass, then differentiating both sides of the above equation with respect to time gives Vg equals m1 v1 plus m2 v2 etc. into mn vn, all divided by m total. Consequently, mvg equals summation mi vi, but mvg is the linear momentum of the center of mass of the system. Thus, we get a conclusion which says that the linear momentum of a system Pg equals mvg equals the linear momentum of the center of mass of this system. So as a conclusion, the linear momentum of a system P system equals m1 v1 plus m2 v2 etc., which is summation mi vi, or P of the system equals P of the center of mass of this system. Consider this application. Two particles of masses m1 equals 1 kilogram and m2 equals 2 kilogram move toward each other. Move towards each other means their velocity vectors have opposite directions. With respective velocities of magnitudes, v1 equals 2 meters per second and v2 equals 1 meter per second. Kindly look at the figure. Questions are: Part A, determine the linear momentum of the system composed of both particles. The linear momentum of the system composed of both particles is P equals m1v1 plus m2v2 equals 1 into 2i. Why 2i? Because v1 has the same direction as the positive x-axis, plus m2v2, which is 2 into minus 1i, because v2 has opposite direction to the positive direction of the x-axis. So 2i minus 2i equals 0. Consequently, the linear momentum of this system equals 0 vector. In part B, say whether the center of gravity of the system made up of these two particles moves and justify your answer. The linear momentum of the center of gravity is equal to the linear momentum of the system. So P equals mvg equals 0. Consequently, Vg equals 0. We conclude that the center of gravity of the system remains fixed. This is the end of the session. Thank you and have a nice day.